lesson 9.3 for Algebra 2, arithmetic sequence and series. And yes, that looks like arithmetic, but for some reason when we're talking about sequences, we call them arithmetic sequences. Must be some kind of language difference from some other culture, but I'm not sure. So what we're going to do this time is focus specifically on one type of sequences called arithmetic sequences. So the first two lessons we were looking at a variety of different kinds of sequences that have different patterns to them, and these will all have a very specific pattern, which makes them arithmetic. And then 9.4 is on geometric, so that's also another specific one. So if you have your page of formulas that I put out there, you can focus basically on the section that says arithmetic sequence formulas. So what is an arithmetic sequence? An arithmetic sequence has successive terms that go up or down by the same amount. So this is the cost of mailing a letter in 2005 per ounce. So 1 ounce you paid 37 cents, which has gone up a lot since then. And for every additional ounce, you pay an additional 23 cents. So these must go up or down by the same amount every time. This number is called the common difference, and we use the letter D. It can also be negative. If it's going down, it would be negative. Okay, so that's important to know that that is the difference, the common difference. It's common because it's the same all the way down the sequence. So if we have a arithmetic sequence, we can find the common difference and the next term. So first of all, you got to make sure it's arithmetic. So how do you check and see if these all have the same difference? You subtract because it's differences. Sometimes I start on the right, sometimes I start on the left, but basically how far apart are these? You're doing -4 minus -10, which is 6. -4 minus -10, remember add a line, change the sign, is 6. And then we have 2 minus -4, which is also 6. So I'm going up 6, up 6. This one you can probably figure out pretty quick. It's up 6 and up 6. So the answer is yes, it is arithmetic. Arithmetic. The common difference is 6. And then the next term then, well, I can find the next term would be 20. 14 plus 6. A 1, 2, 3, 4, 5, 6. So for this problem, I could say a sub 6 is 20 for the next term. And that answers that one. So if you think that was easy, you can try this one out. But first, make sure it is arithmetic before you answer that. So if you subtract these, that's going down by 3. That's going down by 6. That's going down by 9. This is not arithmetic. If these are not the same, it's not arithmetic, and you're done. All right, if it is arithmetic, then we have a few formulas that can help us out. I talked about these a little bit as these sequences came up in earlier lessons, but now we're going to write them out. So first of all, a recursive formula for an arithmetic sequence is you just take the previous term, whatever you had, and you keep adding that difference to it. So for the third term, you take the second term plus the difference. For the 10th term, you would need the 9th term plus the difference. So for this recursive formula, you would have to have all the previous terms in order to find the next term. We can also do a general or explicit formula for the nth term of a sequence. And this formula is on your formula sheet. So it's one that you don't have to memorize, but it's super useful. So to find the nth term, I need to know the first term, the common difference, and then whatever term I'm looking for, I just subtract 1. So we did this in one of the previous lessons, but basically if I want the 10th term, I need to add the common difference 9 times to whatever I started at. So let's practice using that formula. We want to find the 12th term. So notation, we're looking for a sub 12. And the formula, in case you don't have your formula sheet handy, is a1 plus n minus 1. Sorry. N minus 1 times d. I forgot my parentheses. So for this one, what is my first term? Well, a1 is my first term is 20 plus n is the term I'm looking for. So that's 12 minus 1 goes there. And then d, I have to find the common difference. You should probably make sure it's an arithmetic sequence before you start. What's happening here is I'm going down 6, down 6, down 6, down 6, all the way across. So this d is -6. Okay, and then we just type that in or figure it out if you want to, but 11 times -6 would be a negative 66 plus 20, so negative 46. All right, so the answer to this problem is negative 46. I should definitely see this much work, okay? You have to show me that you're using the formula, or you really could write it out 12 times, but that would take even longer, I think. Again, if you think you have the hang of this, pause the movie, see if you can find it without me. All right, we are looking for the 11th term. So we're going to take the first term plus the number of terms minus 1 times the common difference. Common difference? These are getting further and further negative, so they are subtracting 2. So my common difference is negative 2. 10 times negative 2 is negative 20, so the answer is negative 23. That would be my 11th term. Okay, this is a little different. Now I'm missing the middle part of my sequence. I know the first and another term, but I don't know what's in between there. So they're telling me that it's arithmetic, so there's no guessing there. What I know is the first term, and I know the fifth term, right? 1, 2, 3, 4, fifth term. I know the fifth term is negative 7. So you could probably use logic and figure out how many common differences are you going to need. You're going to need 4 of them. So there is a way to do this. I'm going to show you the way with the formula, because when we get to the next section, 9-4, it's a little bit harder because it's not just adding. So what I would do is take the formula that we have for finding the nth term of a sequence, and we know the fifth term, so let's just use that and set this up and see if we can figure out what the difference is, because that's the thing we don't know. So for the fifth term, I would need the first term plus n minus 1. Well, my n is 5 if I know my fifth term. My fifth term is negative 7, so I'm just going to put a negative 7 here instead of my fifth term. And then the only unknown in this equation is a d. So I can solve this problem. I have negative 7 equals 17 plus 4d. So just do some algebra here and solve. Negative 7 minus 17 is negative 24. So then I divide and I get negative 6. So now that I know what my common difference is, I can just subtract 6, subtract 6, and find out what each of these are. So my missing terms, my second term would be 11. My third term minus 6 would be 5. My fourth term minus 6 would be negative 1. And then if I subtract 6 again, I would get negative 7. So I know that I'm right because I filled in the 3 blanks and it still works for the pattern. So for the final answer, I've got these 3 terms, but in order to get there, I had to find that common difference. So again, make sure you're showing some work. Just to kind of go back real quick, if I was using just the fact that I know this is arithmetic, which is subtraction because it started high and went low. If I did negative 7 minus 17, I know these are 24 apart. Actually, negative 24 apart. And I know that there are 4 steps to get there, 4 changes. So you can also just kind of look at it. But if you do it this way, make sure you write something out to me so I know where you got your D, and then show the answers. Let's try another one of those just so you get a little bit of practice. So this one, the first term is a 2. And this is the 1, 2, 3, 4. It's the fifth term again. So I'm going to start with my fifth term. Take the first term plus 5 minus 1 times d. So I need to figure out what that will be. So let's subtract 2. Divide by 4. Looks like it's negative 1/2. So 2 minus 1/2 is 1.5. You can do this in fractions or decimals. Subtract 1/2, subtract 1/2, subtract 1/2, and that would work out. You can also notice that this is a difference of 2, and we need to divide that by 1, 2, 3, 4 changes. So it's going to go down 1/2. I have another example here, and this time we don't have the first term, and another time we just have like 2 terms in the middle of the sequence. So to get it set up, I'm going to put my 8th term here and my 14th term here, just like they're the first and the last, but not really. And I need to figure out how many steps there are in between here too. So first I'm going to just do it the easy way, probably 157 minus 85. So subtract those, and that's 72. And then figure out how many steps this would be. From 14 to 8, that would be 6 steps. So 72 divided by 6 is 12. So now I know my common difference is 12. And knowing that, you can go up to fill in these blanks. You can go back. So since this is 8 and I want number 5, I can go down 12, down 12, down 12 3 times. So I can subtract 12 times 3. 85 minus 36 is 49. So the 5th term is 49. Now, algebraically, using the formulas, we can also do this. So let's just pretend like kind of like this is the first and the last term. So we'll take the a sub 14, which is the 157 because it's the bigger one, and just pretend like this is the start. So if I start with 85 and I add my common difference, how many times would I add it? Well, it's not going to be it's not going to be 14 minus 1. It's going to be 14 minus 8. And that's basically what we did here. This is where the 6 came from, was 14 minus 8. So we can solve this. 157 minus 85 is 72. And then we divide it by 6, which is 12. So either way, to get your common difference of 12. And then from 85, you're going to subtract 12 3 times to get your 5th term for your final answer. So definitely on this problem, I don't want to just see a final answer. I need to see something that shows me one way or the other how you got the difference of 12. Let's try another one of these. This one's a little bit easier because they gave you A2 and A3. So you should be able to figure out your common difference just by subtracting them. So if you subtract those, you get 12. This is going up from negative 133 up 12 to 121. And then you could find the 11th term by taking, well, we could just go down one more and find the first term if we wanted. Or we could start at the second term and find the 11th term. We could just keep adding 12. There's so many ways to do this. All right, let's just use this. What if I started with the second term? What if I started with negative 133? Then how many times am I going to need to add the common difference? Well, if I'm looking for the 11th term and I started on the second term, then I would subtract 11 minus 2 instead of 11 minus 1 because I already did part of that. And that is all you have to do for this problem. So negative 133 plus 9 times 12. The 11th term would be negative 25. All right, so we also have already learned a little bit about series. So if I have arithmetic sequences, I can also add them all up, and that would make them arithmetic series. So you're going to see some more of that sigma notation now. And I actually talked about this formula a little bit when I talked about series, but this is on your worksheet. Formula sheet with the formulas. The difference now is that we have an S here because we are summing up all of the sequence. So remember, if there's an A, that's the term number, just finding that one value of the one term. And if there's an S, then I'm adding up all of the terms up to that point. So if I want to find S18, I would use the formula. Well, let me show you the formula. It's A1 plus AN times N over 2. In order to use this formula, I have to know the first term and the last term. If you have my formula sheet, you'll notice there's another formula on there, and I'll show you that one in a minute. But in order to use this formula, we have to have the first and the last. So first, we have to find A18. We need to find what is term number 18. So to find A18, we're going to use that first formula, which is first term plus 18 minus 1 times the common difference. These are going down 11, it looks like. Yep, times negative 11. So if I do that, 13 plus 17 times negative 11 is negative 174. That is my 18th term. So that's a sub 18. So in order to do my sum now, I know I'm going to have 18 terms. The first plus the last divided by 2. So my answer for the sum, if I added all of these up for the first 18 terms, would be negative 1449. Okay, the other way to do this is to use the second formula on my sheet, which is n times 2a1 plus n minus 1d all over 2. So it's very similar. You notice there's an a1. And then this stuff that's in here is basically taking this extra step that we had to do of finding the last term and putting it in the formula. So using this formula, I would get 18, 2 times my first term, because it's here and it's here. We used it twice, plus 18 minus 1 times my common difference I already found is negative 11. And then I divide all that by 2. So if you type that in as well, there would need to be another parenthesis on the top. So you got to do all of your top and then hit divide by 2. Make sure you don't divide by 2 without parentheses there, or you will have some problems. All right, so that's basically using either formula. It doesn't matter which one you use, but using the first one, you have to find a sub n. So that's why there are 2 on your paper, just to make that a little bit easier. And you can have those with you. If you want to check this with your calculator, you would use those buttons that we did last time under second, stat, and go over to math to find sum, and then second stat, and go over to ops to find sequence. And then the sequence, in order to do that, you would have to write what the formula for the sequence is. And the formula for the sequence was 13 plus n minus 1d, which was negative 11. Make sure you put that in parentheses. So they put it in like this. You can also clean this up. That's your sequence. Variables x from 1 to 18, step of 1. And then you want to sum those up with the sum. Anyway, we got the same answer. You can do it on the calculator as well. But if you are, make sure you show me your work of what your sequence is. Okay, what we have been doing are actually called partial sums because they are sequences that are finite, that stop. You can also, some sequences you can do infinite sums on, but you can't with arithmetic, because if we're always adding the same amount every time, this is never going to add up to something, because it's just going to keep getting bigger or smaller indefinitely. So we are always going to do finite sums for arithmetic sequences. So here's a couple more, just in a little bit different notation. Find the indicated sum for the series. So this first one here is in summation notation. And we want to find the first and the 15th term so that we can do the sum if you want to use this formula. If you want to use the other formula, you just need to find the common difference, which is also not really given to us. So either way, we're going to have to do a little bit of work. So let's find the first term first. Plug in a 1. If I plug in a 1, I get 7. The nice thing about this being in explicit form is the 15th term is really easy to find. Plug in a 15. 15 times 2 is 30, plus 5 is 35. So right away, I have my first and my 15th term. Almost as easy as finding the common difference. Because to find the common difference, I would have to find the second term and then figure out what the difference is. It's 2. All right, now I can find the sum of the first, find the indicated sum, which is S15. So I want to find S15. So it's 15 times the first plus the last divided by 2. And that's all we have to do. Just make sure we use parentheses in the right spots. And I got 315. Again, if you want to check this on your calculator, you would just need to write the sequence out in a notation that would work, and then add it from 1 to 15. So 7 plus x minus 1 times 2. You don't see that here. You should be able to enter this as well. This would be a formula you could put in there. I'm not sure why they changed it, but anyway, that concludes lesson 9.3.